Hey there, chemists. We made it through another week. All the way through to week 7. We have just 3 weeks of our quarter remaining. So I wanted to start off with sharing a little bit of a highlight from my week, which was looking through your lab selfies from last week, your lab 6 selfies. We had a little bit of a competition for best selfie, lab selfie, and I wanted to share with you, with permission, the winner. Someone had a little bit of fun with their test tubes and some Sharpies, and I got quite a kick out of that, and I love that because a day without laughter is a wasted day. So congratulations to all of you. Anyone who participated in the competition received 1 extra credit point, and anyone deemed a winner got 2. So congratulations, and I really love this. Okay, so some other highlights from the week. Our Unit 3 test opened on Friday, closes on Sunday, so make sure that you make some time to take that as soon as you can. Not related necessarily to the class, but registration for summer quarter and fall quarter did open this week, so hopefully you got some time to meet with an advisor and register for classes if you're in that group of people. Okay, so our week 8, it's week 7, sorry. Another typo. Our week 7 learning outcomes. I'm just so excited for week 8. I just jumping ahead. Our week 7 learning outcomes, we really were focusing on water and the making of solutions. So we got to look at water and some of its unique properties, what happens to things when they dissolve in water, when they seem to disappear, what's really going on. And it's a little bit more complicated than the average person might realize. We got to talk about my favorite molecule probably in the world besides insulin, which is soap. Soap has the dual personality, a polar and a non-polar portion, which allows it to kind of speak the language of both solvents. It can dissolve into a polar solvent by tucking its tails away inside, or it can dissolve into a non-polar solvent. And therefore, we can use it to clean up otherwise difficult things like oil. If you spilled oil, maybe vegetable oil in your kitchen, it's really hard to wash away with just water, so you're going to need that multi-personality soap molecule. So let's look at some of those discussion questions. So your guys' discussion posts that I looked at for this were spot on. People were able to pick up pretty quickly. This is a fun demo that you can easily do at home. It's not particularly unsafe, though we always want to be careful. And yeah, it gets right down into water's unusually high specific heat capacity. So that's essentially its ability to absorb heat without raising its temperature much. Water can absorb a lot of energy before its temperature moves at all. And so because of that, by putting the water in the balloon, the heat is essentially like, rather than impacting the rubber of the balloon, it's going to the water instead. And so you can get it much closer. It's a really terrifying demo for me to do because sometimes it does still pop and you never know when, and then you just splash water everywhere and scream like a girl in front of your class. But it's always a really fun one, and I enjoyed the discussion that I saw on that. So great job there. This question is probably one of my favorite ever, and I'm sad we weren't able to do it face-to-face because I kind of enjoy the back and forth. You might have noticed I commented a lot because I do know this is a challenging question, and I wanted to make sure people were picking up, because A is kind of that most we want to pick A, and we want to pick A because that's the picture that we've seen in our textbooks or in the videos in the reading when we talk about the micelles or micelles, depending on how you pronounce it, of soap and how they interact. But all of those pictures are referring to soap interacting with water. And the reason soap assembles through that molecular self-assembly into that structure that we see in A is because those little circles there in our soap molecule, they're polar. Actually, they're not even polar. They're flat out charged. They have an ionic charge. And that makes them very, very attracted to water, or water very, very attracted to them, whereas water is not particularly attracted to that non-polar hydrocarbon tail, which we call hydrophobic, as if it were water-fearing. Really, it's just that water is so much more attracted to the head that it pushes it out of the way, like, you know, like, get out of my way. I want to interact with this charged particle, and therefore we get that particular micelle with the polar heads on the outside interacting with water, and the hydrophobic or non-polar tails toward the middle. But liquid hexane, or hexane, is not polar. Liquid hexane, if you look at its chemical formula, it's only C's and H's. Anytime you have a compound that's only C's and H's, it's nonpolar because the carbon-hydrogen bond is nonpolar. In fact, it's our cutoff for defining nonpolar. We use that electronegativity difference between carbon and hydrogen, which is 0.4. We use that as scientists to decide. That's our marker for nonpolar. So all hydrocarbons are nonpolar. So therefore, if you put soap in hexane, it will dissolve and it will self-assemble in a very similar way to it does with water. But the hydrophobic portion is actually going to be the lover of the solvent this time because like dissolves like. So the nonpolar tails are going to interact with the solvent and our polar heads are going to end up pointed toward the middle. And so you see there that B, the inverted looking micelle, is the structure that we would expect to see at the misfrizzle level. So we'd still be making micelles, but they wouldn't look like the micelles we're used to, that we see when it dissolves in water. So our other question, obviously this is an opinion question, so you know, what do you think? What do you think the most interesting or unique property of water is? And there are so many to choose from, and I don't even always know which one mine is. So here's a list of some possibilities that you might have thought about. Water dissolves more stuff than any other liquid on Earth. It's a tiny molecule, so it's not like big and bulky, you know, keeping stuff from going into solution. And then it's polar. It's actually really polar. It's especially polar. It's hella polar, which means it's going to dissolve polar compounds really well, and then ionic compounds are really likely to dissolve in it. So more than any other liquid on Earth. It also has, like we talked about, a crazy high specific heat capacity. It can absorb a lot. It's hard to change its temperature, and that's a really good thing for life on Earth. If its temperature swung wildly back and forth based on the sun going down or up, life would be different or maybe impossible on Earth as we know it. A fascinating thing about water is not just its high specific heat capacity, but specifically how much energy it takes to get it to go into the vapor phase, from liquid to, you know, either to evaporate or boil away. That's huge. It actually takes more energy to get water that is already at 100 degrees Celsius to go into the vapor phase than it took to get from 0 to 100 degrees Celsius. So the amount of energy that the water had to absorb just to get from 0 to 100, imagine it was like this. Now that it's at 100, the amount of energy that it takes to boil to go into the vapor phase might be like this. It's actually more than the whole amount of energy before. That's crazy. It's just mind-blowing. Because of that, water has a high boiling and freezing point for its size. Carbon dioxide is essentially about the same size of a molecule, but it's definitely not a liquid at room temperature. It's a gas. And it's, you know, its freezing point is in the severe negatives. So that allows water to be a liquid at room temperature, and we learned last week on why that's so important for living things. It's actually pretty unusual for a molecule without carbon to be a liquid at room temperature and pressures. It also has a higher surface tension than most other liquids, and we see that in its little, you know, it makes little droplets so well. And then a high degree of cohesion and heat and adhesion. And if you move on in chemistry or biology, you'll learn a little bit more on why that's so important, especially for things like plants. And then, as again we learned about several times, it is less dense as ice. This is unusual. Most substances don't become less dense in their solid form. And that also provide some important things for life on Earth as we know it as well. So lots of different things we could pick for what's your favorite. In terms of what accounts for this, I feel like every single one of these comes back to hydrogen bonding. Water's ability to engage in that particularly strong intermolecular attraction where every water molecule is attracted to every other one. And even though that attraction is small compared to a covalent or an ionic bond, when you're talking about this constant forming and reforming of bonds in water, it turns out it makes a really big difference, particularly in terms of like that melting and boiling point that we talked about. So what's next? Where are we going from here? Well, As you're probably paying attention, we have very little bit of time left. The last day of the quarter is technically June 12th, I believe. So we just have 3 weeks of class left. So what we're starting is Unit 4. We're going to be getting into Unit 4. We'll spend week 8, 9, and 10, which is also kind of our finals week. We'll spend all of that in Unit 4. And we'll talk more about what that end of the quarter will look like later. For this week, we're going to be focusing on concentration. Now that we've talked about dissolving things, how then do we quantify that? How do we measure that? We're going to talk about osmosis. And then a very applicable example of concentration in our lives, the Flint water crisis. So what do you need to do? What's next for you as a human being? Wrap up anything that's left over from the last module. So you're going to want to make sure you take your exam, finish up your lab, post your selfie for the lab, etc. Check on feedback on any graded work. If there's something that you think is marked wrong incorrectly, let me know. Or if you want, if you have questions over what was marked wrong and why, again, let me know. And make your initial post to next week's discussion, which is already posted. So Monday is technically a holiday. So you're going to probably want to think about getting your post in a little bit earlier. So maybe, post your initial thing on Sunday. I'm still keeping with the Monday due date, especially since it is just a kind of an opinion and you don't have to be right on it. However, on Monday, I will not be having office hours or the coffee social Zoom that some of you come to. So you're welcome to email me and I'll try to get back to you. I'm actually probably still going to be working, trying to catch up on some grading, but I'm taking it off in that way. So anyway, check your learning outcome and to-do list as always and start, working your way through it. I want you to pay a special attention to the reading this week. Partly just, the book stuff. Some of those discussion questions do come right from the reading, and I should be able to tell from your responses that you're doing those readings. And some of the ways you're answering, I'm like, did they read it? Did they realize this question was answered in the first paragraph? So do make sure you're doing that book reading. And also there is an article referenced in there as well that relates to the week content and you need to read. In order to both encourage, motivate, and reward those who do so, the extra credit opportunity for this week will relate to either the book reading or that article. So there will be a question on the upcoming quiz for next week that will relate to the reading. So read through those and be ready for that. I hope you guys have a good weekend and are able to engage in self-care and take a little bit of a break maybe on Monday. Anyway, either way, stay safe and have a good weekend.